Okay, so on this third video, what I want to do is I just want to give you some teaser information on how you can do custom characters like these, like this heart and a smiley face, and of course I got a little dancing guy. And by the way, this one is already built into Arduino, so that was easy to get to and look at. So if we go here to File, go to Examples, go to Liquid Crystal, and go to Custom Character, you'll see that what we end up with is a sketch that looks very much like our other ones. It has all the basic setup information, so we're going to leave it exactly as it was as a default by Arduino. And of course we're going to create an object, the LCD object. So we have this header, this information here, which we need to be able to reference and establish and build the connection to the LCD. And this becomes new. This is the custom characters, and they're actually called in the form of a byte array. Okay, so each one of these is a byte, but this is an array of bytes. Okay, it's 8 bytes, and you can see its size is specified right here. So it's got a total of 8 bytes. Each one of these is a byte designated by this B. Okay, so what you're actually seeing when you see a 1 versus a 0, you're seeing a light on versus a light off. If we look at this, I'm going to turn the contrast. Each one of these elements is actually an array of 5 by 8. Okay, so we have a 5 by 8 array, and yeah, we have a 5 by 8 array. I'm sorry, and that 5 by 8 array is designated here. So you see these 5 zeros. Okay, and now we have a 1, a 0, 1, 0, 1. So what you're doing is you're actually telling it explicitly which of these elements actually get lit up. Okay, so here we can see in the heart, the top 2 right here are lit up. That's going to be designated by these 2. Then we go down 1 row below, and it's lit up all the way across, where we can see that there, and then of course it tapers down to the bottom of the heart. And if we look at the smiley face, you know, we can probably see, oh, here's the smile, here's the 2 eyes. And if we get down to, actually the frown's not displayed. If we get down to this, we can see our head of our guy, and then the arms are down, and then here you can see the arms are up. Okay? And then what ends up happening is you have to create the character so that the library can use it. And what it does is it links it to a byte value. Okay, you can only, I think you can only handle 8 of them if I'm not mistaken. You can't have that many of them in a particular sketch. And then this is calls to those actual arrays. So we can see that's the heart array. And the heart array now has a value of 0. Okay, and the smiley array now has a reference value of byte of 1. Okay, so if I go down here and I call byte 0, I'm actually calling the heart. All right, and then down here you can see that we do it a couple of other times. We LCD write the value of 3, and we LCD write the value of 4. All right, now there's a better way to look at this. I think this is cool, it's fun, and it's right there at your fingertips. But let me get rid of that. And let's do it a different way. I'm going to go ahead and type in, this is what I chose to search, LCD Custom Character Arduino. Of course, the very first link is going to be to the web page by Arduino that actually explains what's happening, an excellent reference. And then the one I'm really interested in is this LCD Custom Character Generator. So I want to generate my own character. So what you can do here is you can simply select which ones you want on versus which ones you want off. So I think I'll make a cheesy little tree here. There we go. And I'll actually just copy this whole thing and paste it into a new sketch. Okay, so this is our setup. Okay, in its minimal form. We include the library, we tell it exactly which pins we're hooked up to. And here's my character that I just pulled off of here. And we're only going to run, we don't even have a loop. It's just going to display one character. Okay. And oddly, I'll show you this, it doesn't work. There's been some change in the way between the time this was written and the time this has been, this edition of the Arduino compiler. But we can fix it easy. It just doesn't understand the value of 0. It thinks it's an integer, and it's not. This command is not able to accept an integer. And we have two options. Option 1 is we can cast it as a byte. So now we're going to tell it explicitly, no, wait, we did not mean to make that an integer. We meant to make it a byte. So we force it to be a byte by casting it as a byte. And then it's going to recognize the byte value, and lo and behold, we get a tree. Now, the way that I prefer to do it is I like to come up with a name that makes sense. So I'll call this tree 1. Okay. And I'm going to now go down here, and I'm going to make myself a byte variable. And I'll call it, I have to give it a different name. And I'm going to set it equal to 0 because that's the one I want it to be. And then this 0 is going to be a byte because I've defined it as such. So it knows that tree 1 is in fact equal to byte value 0. So what I want to do now is I want to replace this tree 1 with this. Okay. So now I have this tree 1 linked to the byte value of 0. And I have renamed the 0 as tree 1. So therefore, I can just simply call tree 1. And I think this makes more sense, actually. So if I load this up, you can see that it'll do exactly the same thing. Okay, it understood it. Let's make another tree. Let's make one that's got some empty spaces here. So it looks a little different. I'm going to go ahead and copy this, just that right there, and I'll paste it right here, and I'm going to call this tree 2, and I'll make my variable here tree 2, and I want tree 2, I should have come up with a better name for this because I want tree 2 to actually equal 1. That was a poor decision on my part, but that's okay. And I'm now going to need to create that character. So I want the second tree, tree 2, to actually have a byte value of 1. So now if I want to call tree 2, I can simply do this. Okay. And by doing so, I might have to clear it. Oh, no, it did fine. Now you can see we have our second tree that appeared in there. So, let me pause this and I'll do a simple little flip back and forth. And I'll be right back so we don't waste time. Hold on. Okay, so I've taken and written something really short here. It's just going to go ahead and alternate between the two trees. And because I haven't told anything else otherwise, it's going to just automatically advance it along the LCD. And eventually, actually, it's going to overflow its little memory here. And it'll probably start printing it down here because it can actually handle a string that's really quite large. And then you could, of course, scroll it like you saw in the last video. But there, it ran out of memory. Now it's started on the second one. And if I wanted to maintain its position, just make it go back and forth, what I'd probably have to do is I'd have to clear the display, and then I would have to tell it exactly where I want it to be. In this case, I've actually told it to be at home, and I'm going to do that again right here. So that way, when I load this, you can see what it's going to do is clear it. I'm going to tell it to go there. It's going to print the first tree, then it's going to clear it, tell it to go there, print the first tree, or second tree, and it's stuck in a loop. I could have actually made this a particular position, of course, but I'm sorry, this particular position, but for this demonstration, I'll just keep it right here. Okay, so the next thing I wanted to show you was that little thing that I had written. So let me pause this and pull it up. Okay, so here's my little Pac-Man guy. And I did it over here. I just drew a Pac-Man, and then I saved it. And then, of course, if you look at my guys, there's actually a couple different characters. There's this guy with him going to the right, and this side going to the left. So there's two of them with his mouth open, one going right, one going left. And I also switched the eye position. Okay, so you can see now the eye is on this side, and so therefore I switched the eye to that side. So there's actually 4 different Pac-Mans. Okay, 2 of them going left, 2 of them going right. And then I had my little cherry. And you'll also notice I actually did this slightly different, only because it saves space, but ultimately, you know, what I've done is I've reduced it down from 10 lines down to 2. But if I wanted to bring it back, it's really just that. Okay, all I did was remove that space. And now I've got essentially the exact same thing. Okay, let me tidy that. And you'll see it looks very, very similar. All right, I just had reduced its size quite a bit. Here again, I created my byte variables. Okay, they're bytes, and I have 1 through 4. I have my, 1 through 4. So I have my 5 different characters. I also created a global variable that I'm going to use for my loops because I want to know where it is, where the character is in multiple functions. And then I created a variable that's going to hold the position of the cherry. Okay, and this is something maybe I haven't done yet. I've created a Boolean. In other words, just a true or false. And what it is I want to make sure I've created a variable called first run, and I've set it to true. That way I'll know if it's the first time it's been run or not. If I put it so that I flip it to false, that way I'll be able to query to see whether or not this is the first run or if it's been in a loop for a long time. And I'll show you why that's important in just a moment. I created all the characters with the LCD create character, of course, and I carried them over so I know their byte value, and then here's the names. And of course now I know that, for example, Pac-Man close going right is 0 because I've created it that way. And the 1 here designates a Pac-Man close going left, and then I've assigned it, created the variable, and I put that byte value 1 linked to this. So now they all have logical names, which I think is so much easier to deal with. That cherry gets generated in a random location. You never know where it's going to appear. And I'm going to use a random seed to do that. Okay. And all I've run is one function here, and I just called it demo. And here's that Boolean. Okay. So remember I started it off at true. And what happens is the very first time this function runs, it says, oh, is it true? Well, then I'm going to actually assign a random location for the cherry. And then I'm going to set first run to false. So the next time it runs in this loop, it's going to say false. And there's no way to switch it back to true in my function. So it'll only do this once. Then that's only going to be the very first time it runs. So now what I'm doing here is I'm simply making my Pac-Man open and close his mouth. Okay. So I have the open and the close, and I have it moving along the axes. Okay. So I place the cherry down. Okay. And it's going to stay in its location because its location is fixed, right? Its location was chose right here. I is going to be shifting by this variable, and then now we see it's open, and then we see it's closed. Okay, so I is going to open, close, open, close, open, close as it goes down the thing. And it's going to do the same thing when it goes to the other direction. Okay, so I set the cherry location to location. It does not move again, but I, all right, is going to go, in this case, from 15 down to 0 because I'm in at this side and going that way. And it's going to open and close. Now, here's the thing. I'm going to go back to these two ifs. If the location, which was generated by the random number, happens to equal I, which is where the Pac-Man is at that moment, it calls burp. And if we go down here, there's 2 burps. There's a burp left and a burp right, okay, because it's going to make that burp move one way or the other. And I'm about to run out of time. So you can see those burps are called, and that's what causes this to scroll. So I'm going to end it, and I'll see you soon.